students, the previous video I have posted, it is about algebra 1. I included there a complex number, then some equations problem and logarithm problem. Very simple problems that you have got. Actually, I have seen the previous question papers, and according to that thing, I am preparing these questions actually. So here I am including arithmetic progression, geometric progression, harmonic progression. Harmonic progression actually it is not in your question paper, but I think you should know these things. And just I am defining these things. Then what I have done here, some series problems, and then some suggested problems. And this is arithmetic progression. Then binomial theorem I am including here, and some problems of permutation combination. So this is covering in this section. So arithmetic progression, you just these things. So a1, a2, a and r in AP. Then this is the mth term is this one. First term is a, and mth term is this one. And this is the sum of first n terms in an AP. Then it is ZP. ZP is the ratio. We say it is common ratio. In arithmetic progression, we need this common difference is the we are taking difference an minus 1, and this in GP, geometric progression, we require this ratio. We say it common ratio. We usually it is denoted by R, and this is the mth term. And this is mth term. Then this is the sum of first n terms of a ZP, and this is infinite sum. Since in AP, infinite sum doesn't exist. Infinite sum doesn't exist, because this so if sum exists, then this tm should be very small. But in this case, we are adding or subtracting some values like this. So usually it doesn't goes to 0. Doesn't go to 0. So that is why infinite sum in AP doesn't exist. But in GP, there is a possibility. When this common ratio is smaller, then r to the power n this converges to 0, and that is why actually it is this limiting case. It comes from calculus, but this formula I am just giving you. It is a by r minus 1 or 1 minus r, like that. A by r minus 1. Actually 1, this is 0. Actually this is sorry, I am just do it. It should be not. This is not actually this one is not it. It is 1 minus r. A by 1 minus r. Not r minus 1. This is corrected. You make it correction. So this is your GP. And harmonic progression is it comes from an arithmetic progression. So see the definition. A1, A2, An is an HP. It's an HP if this difference this difference is same. Means what? This A2, 1 by A2, 1 by A1, 1 by A2, 1 by A3 up to 1 by An, they are in AP, arithmetic progression. So this is common difference. So this is equal to D. This is equal to D. The common difference that we have got in this arithmetic progression. So this thing. So this is harmonic progression, and this result you may remember. Harmonic progression harmonic mean is just to define this arithmetic mean for two values, a plus b by 2. geometric mean for two values, it is root over AB, and harmonic mean is given by 2AB by A plus B. And this is this result you should remember, this is AM, this is the relation, AM is greater than GM is greater than SM. So this is about harmonic mean. And then these are the this formula you should remember. Sum of first and natural number is n into n plus 1 by 2. This you know very well, but these things you should know this. So this is sum of squares of first and natural numbers, and this is sum of cubes of first and natural number. So this result you remember. Then exponential series you know, e to the power x, the e number you know, you have applied this also. So e to the power x is this series, and logarithmic series. Logarithmic is defined for mod x less than 1. So this is this series, x minus x square by 2 plus x cube by 3. So logarithm, this base should be e. And also for x equal to 1, this is defined, but for x equal to minus 1, it doesn't, it is not defined. And for mod x greater than 1, it is not defined. So for mod x means what? If you may say the interval is like this, open for minus 1 and this is closed. So for this logarithmic series is defined. Then these are a suggested problem. So an AP whose nth term is twice n minus 1, you know it very well, this 1, 3, 5, etc. So this is correct. Then ABC are in GP, then B square is equal to AC. So these are very simple. Then a function is defined as fx is equal to twice x plus 1, the value of a for which these are in GP. So if they are in GP, we have to find a. So if they are in GP means what? In place of x you write a. So FA is this one, FA. So FA is twice a plus 1. So this is twice a plus 1. F twice x. So in place of f of twice x, so 2 into 2x. So 2 into, in place of x, twice x, and in place of x you have to write a. So it is 2 into twice a plus 1, and again it will be for 4x, this will be this one. So this means if they are in GP, then what we will have, this ratio is same, and this ratio is the same, this we get this relation. So solving it, we have a equal to 0. So our choice is 0. So for this multiple choice, you can just test. You can test it, and you can write f a 0 0 you put here. So but you have to find this fx, f twice x, and f over x like that. So a is 0 here. Then minimum value of n for 1 plus 3 plus 9 plus 27 plus e to the power n is greater than 1000. So how will you find it? This is sum of this is a GP, 1 plus 3 plus 3 square plus 3 cube. So this is a GP. This a 9 cube, 729, 3 to the power n plus 1 or 3 to the. So this GP is sum is what? So you go to this definition, this definition sum. So Sn is equal to a into r. So there r is 3, and then r to the power n. How many terms are there? Sn. So it starts this one. So 1, 2. It starts at, so there are n plus 1 terms. 1, 2, 3, 4, 5. So n plus 1 terms, and that is why I am writing 3 to the power n plus 1 minus 1 divided by 3 minus 1. And first term is 1. So this is our sum, and this sum is greater than, we are asked that you have to find this sum greater than 1000. So if you write 4, You can test it like this also. If you write 4, then 1 plus 3 plus 9 plus 27, 3 to the power 4. 3 to the power 4 means again one term will come. Then this is, but it may take time. So this sum you find, then after simplification you will have 3 to the power n plus 1, it is greater than 2001, 2000 plus 1, 2001. Then you go on testing for this. For what value you will have minimum value, you are asked to find a minimum value. So 3 to the power 6, it is less than 2000, and 3 to the power 7 will be greater than 2001. So your answer is n equal to 7. Then GM and HM of two numbers 9 and 5.4 is AM is. So GM, you find the formula. So GM is, two numbers are 9, so 9 is equal to root over AB, and HM is, definition of HM is, formula for HM is 2AB by A plus C. So this is given as 2 into 81, because AB is given as 81. So 2 into 81 divided by A plus B. So 5.4 into A plus B is equal to 162, and that is why A plus B is equal to 30. And you are having A plus B equal to 30. Then you test it for this. You partition this, because your A into B is equal to 81. A into B is equal to 81. So you see for what value you can have. You will have 10 plus 20. Then 10 plus 20, 10 into 20, it is 200. It is not 81. So you see test for this. So it is for 3 plus 27, it is satisfied this 30. Also 3 into 27, it is 81. So like this you find the value. It is 3 into 27. Then this one, region of validity expansion for this. So we have defined logarithmic series. So logarithmic series is this one. So this modulus x. So modulus x. So this is what we have got, mod x. So root over 3. Our x is 3x here. So 3x is, so this is 3x, this is 3x. So this 3x, so mod of this should be less than 1. Then only this logarithm series is defined. And or this holds also 3x is equal to 1, and that is why x is less than 1 by 3, and it is for this part it is closed. So this is less than equal to, and so our answer is this one. Then let three positive integers a, b, c are in GP. A, p plus 2 and c are in AP, while a minus 2, b twice c are in GP. Then a, b, c are. So this is given. You find this formula. A, b, c are in GP means what? B square is equal to AC. So this is in AP means what? 2 into middle term is equal to A plus C. So 2 into this is from this one, B square 2C into 4 equal to A. So this one, this is from AP. So 2 into B plus 2 is equal to A plus C, and from this one again it is B square is equal to A minus 2 into 2C. So B square is equal to 2C into A minus 2. So just solve it. It is very simple. You will get the value 4860. And then number 8, it is they are in GP. So they are in GP means they are in GP. I have not solved this one. They are in GP means what? X square. So twice x plus 2 whole square, because they are in GP. So middle term square is x into 3x plus 3. So this is equal to x into 3x plus 3x plus 3. So solving it, what you have, what value you will get for this? Fourth term we require. So x square, you solve it, then you will have the value of x, then twice x plus 2, then thrice x. So you can have the value of r, and you will have this one. Then answer will be minus 72. This is the answer. minus 72. The sum of n terms in series. So how it is coming, you see. So this you write as 11, 103, 10, 1005, etc., etc. So this you write as 10 plus 1, then this is 10 square plus 3, then it is 10 cube plus 5. So you write in this pattern, and then you are having this GP, and extra we are having 1 plus 3 plus 5. So these are sum of first odd terms, first n odd terms, odd numbers, and their sum is this is come from AP formula, and this is come from GP formula. So first GP this is R, here common ratio is R, first term is R, sorry, common ratio is 10, R is 10, also first term is also 10. So you find this formula. So it is 10 to the power n minus 1 divided by 10 minus 1. So it is this is sum, and this sum is n square. 1 plus 3 plus this is n square. This sum is n square, and this sum is this one. So our option is this one. Then sum of 3 numbers in AP. So for this you just find A, B, C, 3 numbers. Then you write A plus B plus C is equal to. So I am doing it. So take the numbers A minus B, A plus B. Then their sum is minus 1. So we are having A is equal to minus 1. So after getting A equal to minus 1, you put the value, and you are having this as B equal to 3. Their product is 8, given as 8. So A is minus 1, that is why is A square minus B square, because it is minus 1. So I am writing B square minus A square, and that is equal to 8, and from this we are having B equal to 3. So these are the value. So sum of square is 4 square plus 1 square plus 2 square is 21. Then the sum of n terms of the series, this one 1 into 2, 2 into 3, 3 into 4. So nth term you try to make some pattern. So Tn is n into n plus 1. So it is n square plus n. So n square plus n. So you make this summation. So this is equal to what? This is equal to, so this is equal to summation, you write summation, then n square plus n, and n is varying from what? Oh, sorry, we are actually we have to write, or yes, it is given, it is 20. So 1, 2, 3 up to 20. So you may write n is varying from 1 to 20. So for this one you are to write 1 square plus 2 square plus 3 square up to 20 square. Then and this one is 1 plus 2 plus 3. So from the formula for sum of square, we have the formula n into n plus 1 into twice n plus 1 divided by 6. And for this formula you write n into n plus 1 divided by 2 and add it, you will have it. Then number 12, it is x plus, I have done this problem. So x is the pth term, that is why we write x like, because a and d are, this is same for all these three. So x is equal to a plus p minus 1 to d, y is equal to a plus q minus 1 to d, and z is equal to a plus r minus 1 to d. So solving these equations, we have this one, and we are deriving this. So this is the solution. Then this is it is like this number 11. So here also you write the common pattern. So Tn. So here we write, so 1, 2, 3. So for the first time it is 1 into 1 plus 1 whole square. For the second time it is 2 into 2 plus 1 whole square. Is 3 into 3 plus 1 whole square. So nth term, or you may write rth term, it is n cube plus twice n square plus n into n plus 1 whole square. So this nth term is this one, n cube plus twice n square plus n, this one. Then this HP. So HP, what you have to do, 12, 6, 4. So this is an HP. This is an HP means, 1 by 12. So it is 1 by 12, 1 by 12, 1 by 6, 1 by 4. This must be in AP, then only you can say it is GP. So see, check it if they are in AP or not. So 1 by 6 minus 1 by 12, how much is this? It is minus 1 by 6, minus 1 by 6 minus 1 by 12, what is that? Minus 1 by 12, I think. No, 1 by 12. 1 by 12, and 1 by 4 minus 1 by 6, this is also 1 by 12. 1 by 12. This one is greater. So D is 1 by 12. So to 6th term, so we have to find 6th term of this AP. 6th term of this AP is here T6. T6 is equal to, first term is 1 by 12. 1 by 12 into first term plus 6th term is 5 into 1 by 12. D is 1 by 12. So it is 1, this is 12, this is 5 plus 1, 6. So this is equal to half. So T6 is half. So because T6 is half, we have to take the reciprocal, then only we will have this HP. So this is, this is in HP. So half is the 6th term of this AP, and 2 is, we have to consider reciprocal. So 2 is the 6th term of the HP. So our answer is 2. Then this is also sum of 3 terms of HP is 37, and the sum of the reciprocal is 1 by 4. So A plus B plus C is 37, is given like this, and 1 by A, 1 by B, 1 by C, they are in AP, and AP it is 1 by A plus 1 by B plus 1 by 6. This you can do by formula also, or you can find, you can check this also. So 1 by 12 plus 1 by 1 by so these are, so this will not come because 0 is here, so reciprocal we can find. We can say if C is 0, then 1 by 0 we cannot have. So this you cancel. Then you try adding this 1 by 5 plus 1 by 10 plus 1 by 22. This, so you check it, or you may use the formula also. 1 by A plus 1 by B plus 1 by C. This will, how will you do it? 1 by sum of HP. HP is A plus B plus C is 37, and 1 by 4. So HP, actually you test it, it is they are in HP or not. 1 by 7, this is not HP, because 1 by 5 minus 1 by 5, this is common difference 0, but this is not 1 by 5 minus 1 by 7. So this is also not coming. Then 1 by 10 minus 1 by 5, 1 by 10 minus 1 by 5, it is it will be minus half, I think, minus 1 by 5, and 1 by 22 by 1 by, so this is also not AP, reciprocals are not AP. So you try for this. So this will do 1 by 12 minus 1 by 10 is equal to how much it is? 20, 1 by 60, I think, minus 1 by 60, minus 1 by 60, and 1 by 15 minus 1 by 12, this is also minus 1 by, you try it and you will have it. So your answer will be, you check it and add it, you will have 1 by 4. Then this first term of an AP is 5 and their common difference is 3, the last term is 80. This is very simple, nth term is 80, so you find n. Then this you see, this is this term, this is series term, this is see, your E series is 1 by 1 plus 1 by 1 by 1 factorial plus 1 by 2 factorial, etc., etc. So in this case you find the nth term. Nth term, you make a pattern, find the pattern. So this nth term is n into n plus 2 divided by n factorial. Then to get exponential series, you have to make this the numerator as 1 or some power of some value. So if so nth term is this, So we can write it like this: n into n minus 1 divided by n factorial, so that we can cancel out n and n minus 1 from this. So n and n minus 1 we are cancelling out, and we are getting n 1 by n minus 2 factorial, and here this n is here, so we are getting 3 by n minus 1 factorial. Then you write what you will have. So the first term will be what? The first term will be it is 3 by 1 factorial, or you may directly write 3 by 3 into 1 by 1 factorial, or you may write 3 into 1 plus next what you will have, it is 1 by so n you write n equal to n, this is first term you write, we cannot have 1 minus 2, so you start from 2. So when n equal to 2, it will be 1 by 0 factorial, 2 minus 2 is 0. So from this you will have 1 by 0 factorial, 1 by 0 factorial plus 3 by n minus 1 factorial. So 3 by n minus 1 factorial, 1 by 0 factorial. So next you will have 1 by 1 factorial, then plus 3 by 2 factorial, etc. And ultimately you will have this as 3 into 1 plus 1 by 1 factorial. Yes, I can do it. This is so first. We will have like this: 3 common, take common, then 3 into 1 plus 1 by 1 factorial plus 1 by 2 factorial. So you break these things, and you have like this: 1 by 2 factorial, then 1 by 3 factorial, etc., etc. So this is with 3, this series is with 3, and plus, and without 3, this is 1 by 0 factorial, then you will have 1 by 1 factorial. So you will have 1 plus 1 by 1 factorial plus 1 by 2 factorial, etc., etc. So this is E. So this is E, and this is E. So this is tri C plus E, this is 4E. This is also you can check it, because our choice are only these things. So this is not e to the power x, this is not e to the power minus x. You remember the series, then you can do it. Then e to the power x minus e to the, this is also not do this is satisfied by this one. So you test it and you will have it. Then this is logarithmic series. You see the definition, and it is given that a is greater than 0. So this is a result actually. This is a result. It is a greater than 0, and you will get this one. So this is our answer. Then this is one. This is e to the power x. This is e to the power minus x. So this is e to the power x. This is e to the power minus x. And their product is e to the power x plus minus x. This is 0. So this is equal to e to the power 0 is equal to 1, because it is product. So these problems, this is about APGP, etc. Then come to binomial theorem. The binomial theorem, it is this is your definition, you have got it. General term is this one. And this we say coefficients. So this is the expansion, and for this combination is needed: NC0, NC1, NC2, NC3, NCn. This values are, we say them as binomial coefficients. And these are some results you have to remember. So this is the odd coefficients. So after C naught, first term you get NC0, next second term you will get NC1, third term you will have NC2. So fourth term will be NC3, etc., etc. So when R is 1, 3, 5, we say odd coefficient, and when it is 0, 2, 4, etc., we say even coefficient. And this result you have to remember. This is actually, this is when you expand this 1 plus 1, 1 plus 1, whole to the power n. So what you have? Then this is a is 1, b is 1. So all are 1 here. This is 1, this is 1, all are 1. So only this remains, nc0, nc1, nc2 up to ncn. So actually, so these are c0, c1, cn means what? nc0, nc1, nc2 up to ncn. So this is 2 plus 2, 1 plus 1 means 2 to the power n. So that is why it is 2 to the power n. And for this one, this you make it minus. You make it minus. You make it minus. Then when you make it minus, this is 0. So and when it is minus, this comes alternately. So this is 1, this is minus sign because it is minus 1 to the power r. So it is because when expansion of a minus b whole to the power n is what? The sign changes alternately. So that is 1 minus 1 minus 1. So these are positive. So from this what you have? C naught minus C1 plus C2 minus C3, etc., etc., and ultimately is equal to 0. Their expansion is 0. So you take out this even coefficients here and odd coefficients to the right side. So they are equal, and this is 2 to the power n minus 1, because they are this is coming from what? They are having equal values, and if we add them, c naught plus c1 plus c2 plus c3 plus c4, so summation of this. So if we write this a, if we write this b, then this is equal to what? A plus b. This is a plus b. So this is a plus b means what? Their sum is to the power n, and because a equal to b means it is half of this, so it is to the power n divided by 2. The value is this, so it is to the power n minus 1. Those this results you remember. This is complementary combination, supplementary combination. This results also I should know. NCR plus NCR minus 1 is equal to n plus 1 here. So this one. These are the binomial theorem for negative or fraction. So this is an infinite series, and so these are the problems you see. So coefficient of x to the power 4. So it is coefficient of x to the power. General term is this one. General term of this, when you expand, you will have a general term is NCR x to a to the power n minus r, b to the power r, like that. General term you compute it as x to the power 7 minus 5. So no x is a, so x is this one, x to the power 7 minus r. So this 7 minus r should be equal to 4. So if 7 minus r is equal to 4, then r should be equal to 3. So r is equal to 3. Then you make NCR, or in place of r you write 3. So it is 7c3, 3 to the power 3, x to the power 4. And you compute the value, you will have 945. Then binomial coefficient of 8th term in this one. 8th term means your r plus 1 8th term. So tr, this is tr plus 1. So tr plus 1, r is 8th term. 8th term means r equal to 7. So you write this is r is 7 here. So then number of terms in an expansion of this. So this expansion is this one is what? This is 1 plus x whole to the power 3. This is 1 plus x whole to the power 3 and whole to the power 6. So this becomes 1 plus x whole to the power 18. So like this one. So like this one. So we are asked how many terms, number of terms. So number of terms, it is binomial expansion. So power is 18. So there are 18 plus 1, 19 number of terms. So the answer is 19. Then the value of this you go to the formula. Is the odd coefficients. Odd coefficients is 2 to the power n is 15 here. So 15 minus 1. So it is 2 to the power 14. Then the term independent of x. So you expand these things. Independent of x, you expand this one because it is product. Product is given. So this one is 1 minus twice x plus x square and this is x plus 1 by x whole to the power 10. Now 1 minus twice x plus, so you for this your general term will be, here you know your general term is this one, NCR e to the power n minus r b to the power there are 11 terms here. Then you multiply these things, then when you multiply these things, then you have to find a term independent of x. So how will you do it? It is independent of x. Here it comes as here terms are NC r x to the power n minus r x to the power n minus r ako hobo etu 1 by x to the power r. So it is x to the power n minus twice r. So this is our general term. N is 10. N is 10. We don't know which one is independent also. So if we consider this one, n is 10 here. This you write n is 10. So 10 minus twice. So this is the general term of this. Now x to the power 10 minus twice. So if this thing is not there, then our it will be 10 minus twice r equal to 0 means what? R is equal to 5. So when r equal to 5, or it is 6 term is will be the independent. But we have to multiply this one. So when we have to multiply this one with 1, this will be this one. So you multiply this with this. So 1 into this one plus, then minus twice x into minus twice x into this one, this term. But when you say minus twice, then what will have? This will be power of x will be 10 minus twice r plus 1, and it is not possible to make it 0 because r is 10 is 10. So this is x minus 3r, x minus twice r plus minus twice r plus 1 means what? It will be 11 minus twice r. So 11 minus twice r we cannot have integral value for r. So this will not come. This will not come. Then x square, we multiply by x square, then x square. So x square into this thing. So when x square into this thing, then it will be 12. So 12 minus twice r will be 0 when r equal to 6. That is why your answer will be independent of x. So here it is r equal to 5, here r equal to 5, and here it is r equal to 6. So it is 10c5 plus 10c6, and from result NCR plus NCR plus 1 is equal to n plus 1CR. So we are having 11c6. So answer is this one. So we are applying this answer. Then this is a plus b whole to the power n, a minus b whole to the power n. Same expansion, but signs are alternate for sign will change alternately here. For odd term it will be negative, for even term it will be positive. For odd r it will be negative, for even r it will be positive. So you add it, and odd terms will be go. Odd r will be go. So your answer is 2 into summation of this, then CR. This is the binomial coefficients, and root 2 to the power 6 minus r. So r varies from 1, 3, 5. So because odd term is negative, so minus minus plus. Even term is positive, so even term will go. So our r is 1, 3, and 5. So answer is this one. Then the total number of dissimilar terms, x plus a whole to the power 100, x minus a whole to the power 100. Dissimilar terms is like this, same problem. So here expansion is 101 number of terms, and here we have to consider even terms. Starting from NC0, 100C0, then 100C1 will go because it is minus, 100C2. So there are how many terms? 51 terms. 51 terms here. So 2 times of this one. So it is 51 dissimilar terms. So the term free from y in the expansion is simple. free from it will be the first term only the first term, because others y square must be there, the term independent of x in this one. So this one is x plus 1 by x whole square, x square plus 2. So this is x plus 1 by 1 by x whole square, and so it is 2 into 7 is 14. So this last term of this one is this one. It is simple. Then permutation and combination. Permutation and combination. This are the results you see. Simple results here that you have got it. So these problems you see, 10 problems I have included here. So these problems, in how many ways can 8 Indians, 4 Americans, 4 Englishmen can be seated in a row? So solve it like this. So 8 Indians, they are all persons. Condition is that all persons of the same nationality sit together. So this is group of Indian, this is group of American, and this is group of Englishmen. This group of Englishmen. So they will permute among themselves, but one Indian will not come into this, or one American will not come into to set of English. So they will stay together. So these three, first thing you make this group, then shuffle them. So group of 3, you are shuffling in them in 3p3 ways. 3p3. 3p3 means 3 factorial. So first thing you do this. So for each 3 factorial, for then 8, this Indian, this will shuffle among themselves in 8p8 ways. So 8 factorial ways. This will permute among themselves in 4 factorial ways, and this is 4 factorial ways. So you multiply this, so this is your answer. Then total digit of 9 digit number, different digits. 9 digit number. So in 9 digit, if it is 9 digit number, then 9 places. So we are having altogether 10 digits, 0, 1, 2 up to 9. So there are 10 digits. So this 0 you have to exclude in this position. The extreme left position you have to exclude 0. So you can fill in 9 different ways. Then this other 8 place you can so this should be difference. So if it is 1 here, then remaining 8 places 1 will not occur. That is why you have to choose out of 9, you have to choose 8, means what, 9p8. So this is our result, 9 into 9p8. 9 to 9p8, 9p8 value, the value of 9p8 is 9 factorial. So answer is this one. Then this is also number of arrangement of the letters of banana. Banana is what you have to do, n will not, 2 n's will not appear adjacently. So these 2 n's will go in between this b and 3a. So you write b, a. First you place them. In how many ways you can place it? How many ways? Because 3 are similar. So it is 4 factorial by 3 factorial ways. 4 factorial by 3 factorial ways you can shuffle it. And then for n you are choosing these places 1, 2, 3, 4, 5. This 5 place you can choose. So out this 5 place you have to choose 2, 1. So it is combination, not permutation. So it is 5c2. So this is 5c2 into 4 factorial. So answer is 40. And then this you have to solve it. np3 plus n, see, you solve it. This is twice n minus 1 into the and you can do it like this also. After simplification you are having twice n minus 3 into n minus 1 is equal to 28, and you know how will you get it. np3 means what, n factorial by n minus 3 factorial, n minus 3 factorial. So n factorial by n minus 3 factorial, and this one is n factorial by 2 factorial n minus 2 factorial. Then n minus 2 factorial. So this is given as 14.8. So after simplification, n minus 3 factorial, this will cancel out this and remains n into n minus 1, and this one, just do it, this, you see this one, and I am explaining this one. So what we have got, what x into, so n factorial divided by n minus 2 factorial plus n factorial divided by n minus 2 factorial into it, this is definition of combination, is equal to 14n. Then this is your n minus 2 will go, so it is n into n minus 1, then plus here also n minus 2 will go and remains n minus 1 divided by 2, this is equal to 14n. Then simplify it, what you will have, twice n, just do it, what is this one, np3 n c n minus 2, then what you are having, and this n you can cancel it, you can cancel out this n, you cancel out this, n will go, so remains 2n minus 1 into n minus 1 is equal to 28, so it is 2n minus 2 into n minus 1 is equal to 28. n minus 2 to n minus 3, how it is coming, 2n minus 3, and c n minus 2, oh this 3, sorry, this is 3 here, this is 3, so there are 3 factors here, n minus 2. So simplify this one, so n minus 1 into n minus 2, so after simplification, and 2n minus 2 into n minus 2 again, so simplify it, and we will have, this is 28, so we will have this as twice n minus 3 into n minus 1, so we will have this twice n minus 3 so we will have it twice n minus 3 into n minus 1, and this we are giving as 28. Now you see these are integral value, so integer value, so this must be integer, so you factorize this 28, so you may have 7 into 4 or 14 into 2, anything, and 7 into 4 is, it is satisfied by this, so if it is 4 then it is n is 5, and if n is 5 then 5 into 2 minus 3, it is 7, so we are having n is equal to 5, so this is your, so and this one I am having, just do it, so n is equal to 5, we will have it, so your answer is n equal to 5. Then it is done, then next one is NC2, and here you see this result, you see these are the binomial coefficients. So binomial coefficients, you check it, you see it, so suppose it is n equal to 2, then 2c0 is 1, 2c1 is 2, 2c2 is again 1. So means what, the this middle term is having maximum value, So C5 greater than C6 greater than C7 greater than C8 greater than C9 greater than C10, and here also C5 is greater than C4. So this is an order, this is the order. So our n is 10, n is 10, and you do n is 10, then n minus 1. So this one is smaller than this, means what, we have to check this one. So if it is 5, this is 6, you check it, this is satisfied or not, 2 is satisfied or not. So you check it for 6 and 7, you check it for 7 and 8, you check it for 8 and 9, then I think you check it and you will have disorder, because this will not do, 1 2 3 this will not do, it must start from 5. So 3 4 5 will not come, 1 2 3 will not come, because they are it will start from this one, because this one this is smaller, n minus 1 is smaller than n, so it will come from this set. So 1 2 3 will not come, 3 4 5 will not come, we check for this one, and from 8 9 10 you will have it. Then number of ways, 11 players. Now it is simple, 25 players are there, so it is 25 player, you omit, 6 are always there. So from this you are choosing 11, you are choosing 11. So in 11, 6 are always there, so we have to find only 6, only 5 you have to find, only 5 you have to choose, 5 from choose. So 6 you omit this 6 from this, because 6 will all come here, and this 5 is excluded, 5 will not be here. So you have to select only 14, from 14 you select 5, so this 14 C5. Then number of numbers not more than 5 digits. So 1 digit number is, it is in 3 ways, one because it is 1 2 3, so 1 2 3, then 2 digit number because they may repeat, so 11 22 33, then 12 23, so it is 3 square ways, this is, so you add these things and you will have, because number of digits cannot exceed 5, so it is up to 3 to the power 5, and you add it and you will have 363 value. So these are simple questions. So simple questions. So thank you. And then next we will do matrix problem. Matrix I will upload. Matrix, determinant, and then so see these things, and if any problem, we'll discuss these things in the class. But before this, you go through this well, so that you can ask some questions, or we can bring some new questions, so that we can discuss in the class. So thank you.